In these two problems, we want to find the vertical asymptotes and wholes of the rational functions where they exist. So a rational function can have one or more vertical asymptotes and one or more wholes, or both or neither. So let's take a look at number 9. Here we have g of x equals x plus 8 all over the quantity x squared minus 1. So I'm going to write that down on the next screen, and we can analyze this to see whether we have vertical asymptotes, wholes, both, or neither. The first thing to do with this function is to factor both the numerator and the denominator as possible. Now in this particular case, we could factor the denominator but not the numerator. So now I have x plus 8 in the numerator all over x plus 1 times x minus 1. Now I'm going to take each factor in the denominator and set it equal to 0, and that will give me values that are not in the domain. Okay, so I let x plus 1 equal 0. That gives me x equals negative 1. X minus 1 equals 0 gives me x equals positive 1. Now when I look at these two factors, I can see that neither of them is going to cancel with x plus 8. These are different factors from x plus 8. So that means that both of these are vertical asymptotes. So my two vertical asymptotes are x equals negative 1 and x equals positive 1. Those are both vertical asymptotes, and that's what we have in this particular problem. So we don't have any wholes because there wasn't any factor that we could cancel, and that's what's called a removable discontinuity, as opposed to the ones that we have, which are non-removable because you can't cancel. Now let's take a look at number 10. In this problem, we have f of x equals x times x minus 4 all over x cubed minus 16x. So again, I'll factor, and since the numerator is already factored, I'll just go ahead and factor the denominator. Okay, so now we have x times x minus 4 in the numerator, and then x times x minus 4 times x plus 4 in the denominator. And notice that we have a couple of removable discontinuities here. So there's an x factor in common to both the numerator and denominator, and an x minus 4 factor in common to both the numerator and denominator. And these are going to cause what we call wholes in the graph. So I have wholes at x equals 0, and that comes from the factor x that canceled. And then I have a whole at x equals 4, because x minus 4 equals 0 tells us that x is equal to 4. So this is part of the information we need, but when we're talking about wholes, we don't just need an x value, we also need a y value, because it's a point as opposed to a vertical asymptote. So in order to find the y-coordinate of the point, what I'm going to do is I'm going to look at the simplified version of my function f of x. So f of x in simplified form is 1 over x plus 4 for this particular problem. So I just simplified, and we've got 1 in the numerator, x plus 4 left in the denominator. So now what I'll do is I'll evaluate f at both 0 and 4 to find the y-coordinate that goes with those. So if x is 0, then f of 0 is going to be 1 over 4. So that tells me that there's a whole at the point 0, 1/4. And then f of 4, that's going to be 1 over 4 plus 4, which is 1/8. So we have another whole at 4, 1 over 8. So those are the two holes that we have for this problem. And we also have a vertical asymptote. And that vertical asymptote is going to be caused by the denominator factor that doesn't cancel. So I take x plus 4, set it equal to 0, and that gives me the equation x equals negative 4. So to summarize this problem, I have holes at 0, 1/4 and 4, 1/8, and a vertical asymptote at x equals negative 4. And that's the end of that problem.